This is SpaceTime, Series 25, Episode 43, for broadcast on the 11th of April 2022. Coming up on SpaceTime, discovery of the most distant and earliest galaxy ever seen, the best image yet of a mysterious object called an odd radio circle, and scientists study two enormous blobs in the Earth's mantle. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart-Gary.
Well, hot on the heels of last week's announcement of the most distant star ever seen, astronomers have just discovered a galaxy 13.5 billion light-years away. That makes this the most distant object ever seen. The findings, reported in the Astrophysical Journal and in the monthly notices of the Royal Astronomical Society letters, have literally changed science's understanding of the early universe and its evolution. This galaxy, which has been named HD1, was already formed when the universe was just 300 million years old. And that suggests that this extends the epoch of reionization, when the first stars began to shine and end the cosmic dark ages, further back by at least 100 million years. HD1 was discovered after more than 1,200 hours of observing time with the Subaru telescope, the Vista telescope, the UK Infrared telescope, and NASA's Spitzer Space telescope. The astronomer who discovered the galaxy, Yuichi Harakin from the University of Tokyo, says it was hard work finding HD1 out of a field of more than 700,000 objects. But its red colour matched the characteristics of a galaxy 13.5 billion light-years away incredibly well, giving him goosebumps when he saw it. Harakin and colleagues conducted follow-up observations using ALMA, the Atacama Large Millimetre Submillimetre Array telescope in Chile, to confirm the distance, which is 100 million light-years further back in space-time than the previous record holder, GNZ11. Astronomers are now speculating on what this galaxy actually is. HD1 may be forming stars at an outstanding rate, and is possibly even home to population 3 stars, the very first stars to form in the universe, which until now have never been observed. Alternatively, HD1 may contain a supermassive black hole, 100 million times the mass of our Sun. One of the study's co-authors, Fabio Picucci from the Harvard-Smithsonian Center for Astrophysics, says answering questions about the nature of a source so far away can be challenging. He says it's a bit like trying to guess the nationality of a ship from the flag it flies while being far away on shore, with the vessel out in the middle of the ocean in a gale and in a dense fog. One can maybe see some colours and patterns on the flag, but not their entirety. It's ultimately a long game of analysis and exclusion of implausible scenarios. One important characteristic, HD1's extremely bright and ultraviolet light. To explain this, some energetic processes are occurring there, or better yet did occur there some 13.5 billion years ago. Now at first the research team assumed HD1 was a standard starburst galaxy, that is a galaxy creating lots of stars at a really high rate. But after calculating how many stars HD1 must be producing, they obtained an incredible, almost unbelievable rate. HD1 must be churning out stars at a rate of at least 100 stars every Earth year. Now by comparison, our own galaxy, the Milky Way, makes about one new solar mass star every year. HD1's starburst rate is at least 10 times higher than what astronomers would expect from these galaxies. And that's when the team began to suspect that HD1 may not be forming normal everyday stars. The very first stars to form in the universe, the so-called population 3 stars, were far more massive, more luminous and hotter than modern-day stars. That's because they were made out of, pretty well pure hydrogen and helium, because that's all there was back then. It was only when those stars died that the heavier elements they made were able to seed the galaxies and produce subsequent generations of stars with high metallistic compositions such as our Sun. Picucci says if one assumes the stars produced in HD1 are these population 3 stars, then the properties they're seeing could easily be explained. That's because population 3 stars produce a lot more ultraviolet light than normal stars. It's how the universe became reionized. And it could certainly explain the extreme ultraviolet luminosity of HD1. However, a supermassive black hole hypothesis could also explain this extreme luminosity. As the black hole gobbles down enormous amounts of gas, high-energy photons would be emitted from the region around the black hole's event horizon. Now, if that's the case, this would be by far the earliest supermassive black hole known, one observed much closer in time to the Big Bang 13.8 billion years ago compared to the current record holder. One of the other co-authors, R.V. Loeb, also from the Harvard-Smithsonian Center for Astrophysics, says HD1 could represent a giant baby in the delivery room of the early universe. He says it's a remarkable feat, breaking the highest quasar redshift on record by a factor of almost 2. Loeb says forming just a few 100 million years after the Big Bang means the supermassive black hole in HD1 must have grown from a massive seed at an unprecedented rate. The team are now waiting for the James Webb Space Telescope to come online so they can use its greater observing powers to study HD1 in greater detail in order to verify both its distance and dig deeper into its identity and composition to confirm if one of their theories is correct. This is SpaceTime. Still to come, the best image yet of a mysterious object called an odd radio circle, and scientists studied two enormous blobs in Earth's mantle. All that and more still to come on SpaceTime. Astronomy's newest mystery objects, known as odd radio circles or ORCs, have been pulled into sharp focus by an international team of astronomers using the world's most capable radio telescopes. When first discovered 2 years ago by ASCAP, the Australian Square Kilometre Array Pathfinder radio telescope, these strange odd radio circles quickly became objects of fascination. Theories on what's causing them have ranged from galactic shock waves through to the throats of hypothetical wormholes. Now a new highly detailed image, captured by the South African Radio Astronomy Observatory's Meerkat radio telescope and reported in the monthly notices of the Royal Astronomical Society, is providing scientists with more information to try and help narrow down potential explanations. These things look like green circles against the blackness of space. And there are now 3 leading hypotheses to try and explain what's causing them. They could be the remnant of a huge explosion at the center of their host galaxy, something like what would be produced from the merger of 2 supermassive black holes. Or they could be powerful jets of energetic particles spewing out from a galaxy's center. Or they might be the result of starburst termination shock from the production of stars in the galaxy. What makes them even more mysterious is that so far they've only ever been detected using radio telescopes. There are no signs of them when astronomers looked at the same part of the sky in optical, infrared or X-ray telescopes. Dr. Jordan Collier from the Inter-University Institute for Data-Intensive Astronomy, who compiled the image from the Meerkat data, says continuing to observe these odd radio circles will help provide researchers with more clues. Collier says people often want to explain their observations in order to show that it aligns with science's best knowledge. But he says he likes the idea of something new being out there, something scientists can't define, and something which defies current understanding. Now, these rings, or circles, are enormous, about 1 million light years across. That's some 16 times the size of our own Milky Way galaxy. Yet despite their enormous size, odd radio circles are really hard to see. One of the study's authors, Professor Ray Norris from Western Sydney University in the CSIRO, says only 5 of these odd radio circles have ever been detected. What astronomers do know is that these spheres of faint radio emissions surround galaxies with highly active supermassive black holes at their centres. But science doesn't yet know what causes them or why they're so rare. Each is at least an arc-minute in diameter, and they're each located some distance from the galactic plane at high galactic latitudes. The possibility of a spherical shock wave associated with, say, fast radio bursts, gamma ray bursts, or neutron star mergers have all been considered. But if related, it would have occurred in the distant past due to the large angular size of the objects. Astronomers with both ASCAP and MeerKAT are now working together to try and find out more about these objects, to better understand their properties, and so try to work out what they actually are. Of course, ASCAP and MeerKAT are both simply precursors to the International Square Kilometre Array project, which is in the process of building the world's biggest radio telescope, so large it'll be stretched across 2 continents, Australia and Southern Africa. Circular features are well known in radio astronomical images, and usually represent a spherical object such as a supernova remnant, a planetary nebula, a circumstellar shell, or a face-on disk, such as a protoplanetary disk or a star-forming galaxy. They could also arise from imaging artifacts around a bright source, caused by calibration errors or inadequate deconvolution. But this class of circular feature in radio images doesn't seem to correspond to any of these known types of objects or artifacts, but rather appears to be a new class of astronomical object. Nora says for now they remain a mystery.
We first found them when we were just getting Cyro's new ASCAP telescope going. We're just sort of ramping it up and checking the system out. And we're just looking at the images of this radio telescope, and we saw these circles on the images. Because when you see circles, first thing you think of, there's something wrong with the telescope. Well, after lots of work, we decided it wasn't that. And things nobody had ever seen anything like this before. So it's taken a couple of years to gradually try to figure out what they are. We really had no idea at the beginning. And we found that these circles, we now know, these circles around galaxies about 1 billion light years away. And this means these circles are enormous, as you say. They're like 1 million light years across. And we also think now they're not actually circles. They look like circles to us, but they're actually spheres, like soap bubbles. But when you look at a soap bubble, you often only see the ring around the edge, and that's what we're seeing here. So we've got these big soap bubbles around galaxies halfway across the universe. And that's really what we're trying to figure out, what's going on now.
I guess the fact that you're only seeing them in radio is interesting too. They're not showing up in X-rays or visible or infrared or even ultraviolet.
No, that's right. So we've looked at all these other wavelengths and there's just nothing there. We only see them in radio. What we do see is the optical and infrared is the galaxy at the centre. And most of them seem to have a galaxy bang in the middle. And we now know it's not a coincidence. The numbers don't work out. And it looks like this galaxy is what's produced it. So what we think is that there's been an enormous explosion in this galaxy about 1 billion years ago, which has produced this giant bubble. And what we don't know is what caused that explosion. There's a couple of ideas that we're looking at. One is that there's been a merger of 2 supermassive black holes. We know that many galaxies have a supermassive black hole at the centre, and we think that they probably collide into each other from time to time. And that's maybe what we're seeing here, is 2 supermassive black holes collided into each other and gave off this enormous burst of energy. The other possibility, we sometimes see galaxies doing a starburst. What a starburst is when a whole pile of the gas in a galaxy suddenly gets turned into stars. So you imagine in our Milky Way, you're looking up in the sky at night, there's lots of hydrogen gas up there. And supposing all that gas was suddenly turned into stars, the whole sky would be really bright. And that's what a starburst is. A whole load of stars being born at once. Except if you're standing on the Earth, you wouldn't see it because you'd be killed by all the cosmic rays coming down from all these explosions going off there. But anyway, both these processes are really quite rare. And that's the other thing about these odd radio circles. We've only found 5 so far, despite a lot of looking. They really are very rare. And as you say, they're very faint. We can only just see them with the most powerful radio telescopes.
If starburst is a possible explanation for them, that would mean a shock front from something that firstly hit that molecular cloud to begin with. That would still tie in with a possible collision between supermassive black holes.
Oh, you're right, yeah. I mean, we don't actually know what causes starburst, but we think they are often triggered when 2 galaxies collide, which may indeed, as you say, cause the collisions of 2 supermassive black holes. So, yeah, it could be either or both of those things. When you get a starburst, you get a whole lot of gas, really hot gas, pushing out of the galaxy, and that collides with all the gas that's out there in space in between the galaxies, and that causes the shock wave.
With the development of the Square Kilometre Array project now proceeding, construction about to get underway, if it hasn't already started, the added advantage that's going to have, that must be something that astronomers are looking forward to.
Yeah, absolutely. So it's really interesting, actually, because we discovered these things using the Australian ASCAP telescope. And the ASCAP is a precursor to the Square Kilometre Array. And ASCAP is, in fact, the best telescope in the world for finding these things. It can survey large areas of sky very deeply, very quickly. But once you've found one, the best telescope in the world for studying them is the Meerkats telescope in South Africa. And that's also an SKA precursor. And so both these telescopes, they are both built to develop the technology for the Square Kilometre Array, but both of them are fantastic telescopes in their own right. So really, between them, they're just beautiful for this work. You've got one telescope for finding them and one telescope for studying them. But SKA is going to be built using the technologies that we've developed with these two telescopes. The SKA eventually is going to be bigger and better than either of these two telescopes. And so, yeah, the SKA is going to be absolutely brilliant at finding and studying these things.
That's Professor Ray Norris from the University of Western Sydney and the CSIRO. And this is Space Time. Still to come, scientists studied two enormous blobs in the Earth's mantle, and later in the science report, it seems no matter where you are in the world, people seem to like and dislike the same kinds of smells. And yes, the most popular aroma in the world is vanilla. All that and more still to come on Space Time. Scientists studying two recently discovered enormous blobs deep in the Earth's mantle have discovered that one of the blobs is almost 1,000 kilometres taller than the other, and it may be affecting plate tectonics on the planet's surface. The findings, reported in the journal Nature Geoscience, could provide new clues on how the Earth's surface got to look the way it does today. The Earth is layered sort of like an onion, with a very thin outer crust, a thick viscous mantle, a fluid outer core and a solid inner core. Within the mantle, there are two massive blob-like structures, roughly on opposite sides of the planet. The blobs, more formally referred to as large, low shear velocity provinces, are each the size of a continent and about 100 times taller than Mount Everest. One is under the African continent, while the other is under the Pacific Ocean. Using instruments that measure seismic waves, astronomers know that these two blobs have complicated shapes and structures. But despite their prominent features, little is known about why the blobs exist or what led to their odd shapes. Scientists set out to learn more about these blobs using geodynamic modelling and analysis of published seismic studies. Through their research, they were able to determine the maximum heights that the blobs reach, and how the volume and density of each of the blobs, as well as the surrounding viscosity of the mantle, might control their height. The results of their seismic studies has led to a surprising discovery, that the blob under the African continent is about 1,000 kilometres taller than the blob under the Pacific Ocean. The study's authors say the best explanation for the vast height differences between the two is that the blob under the African continent is less dense and therefore less stable than the one under the Pacific Ocean. To conduct their research, the scientists designed and then ran hundreds of mantle convection model simulations. They exhaustively tested the effects of key factors and variables that could affect the height of the blobs. These included the volume of each of the blobs and the contrasts of density and viscosity of the blobs compared to their surroundings. The authors found that in order to explain the large differences in height between the two blobs, the one under the African continent needs to be far lower in density than the one under the Pacific Ocean, and that indicates the two may have different compositions and evolutions. The study's lead author Qian Yuan from Arizona State University says calculations found that the initial volume of the blobs doesn't seem to affect their height. The height of the blobs is mostly controlled by how dense they are and the viscosity of the surrounding mantle. The study's co-author Mingming Lai, also from Arizona State, says the African blob may have been rising in recent geological time, and this may help explain the elevating surface topography and intense volcanism which is seen across eastern Africa. The Great African Rift is slowly tearing Eastern Africa away from the rest of the continent. These findings may fundamentally change the way scientists think about deep mantle processes and how that affects the surface of the Earth. The unstable nature of the blob under the African continent, for example, may be related to continental changes in topography, gravity, surface volcanism, and plate motion. Ewan says the combination of the analysis of seismic results and the geodynamic modelling provides new insights on the nature of the Earth's largest structures in the deep interior and their interaction with the surrounding mantle. And so this work has far-reaching implications for scientists trying to understand the present-day status and the evolution of the deep mantle structure and the nature of mantle convection. This is Space-Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that ocean acidification, which is caused by excess carbon dioxide dissolving in seawater and making it acidic, is having an impact on fish genetics and behaviour. A report in the journal The Proceedings of the Royal Society B has found that some spiny damselfish are more tolerant of high carbon dioxide levels in water than others. And so they deliberately bred the carbon dioxide tolerant fathers with sensitive mothers and vice versa to see how these features would be passed on to their fishy kitties. The authors found that carbon dioxide tolerant parent behaviour affected different patterns of gene expression in their babies' brains, with mothers affecting circadian rhythms more, while fathers affected genes related to proteins that help give structure to DNA. A new study has found that treating wounds with an extract taken from wild blueberries may improve the healing process. The findings, presented to the American Physiological Society's annual meeting in Philadelphia, showed that a phenolic extract from wild blueberries improved vascularization and cell migration, critical steps in the healing process, in human umbilical cord cells. Chronic wounds, such as diabetes-related sores and pressure ulcers, may be categorized as non-healing due to the reduced vascularization that often accompanies these conditions. Researchers examined the effects of phenolic extract on live wounds. Phenols are compounds naturally found in some foods that act as antioxidants to prevent or even reverse some forms of cell damage. The authors found that the wounds treated with a phenolic extract showed improved migration of endothelial cells to the wound site and a 12% increase in wound closure compared to a control group. Well, it seems it doesn't matter where you come from. A new study has found that people all over the world tend to like and dislike the same kinds of smells, and vanilla is consistently rated as the most pleasant aroma. The findings, reported in the journal Current Biology, also determined that the least pleasant smell was isovaleric acid that's found in cheese, soy milk, apple juice, and foot sweat. The researchers tested smell preferences in 235 people, including Westerners and representatives from hunter-gatherer lifestyles, farming and fishing communities. They found that the smells people like or dislike are partially determined by personal preference, but also by the structure of a particular odour molecule. And some smells are perceived as more pleasant than others regardless of culture. That's because liking or disliking odours increase the chances of survival during human evolution. When you think about haunted houses and spooky castles, the Queensland country town of Toowoomba doesn't usually spring to mind. Yet this regional centre west of Brisbane is apparently the stuff nightmares are made of. There are at least 50 ghosts known to inhabit the area, such as the Lady in Grey, who's said to frequent the local St Vincent's Hospital. She's said to have been a member of the Sisters of Charity who established the hospital in 1922. She was first seen in the medical ward in the late 1970s and assists patients when staff aren't around. Then there's the young girl who haunts the local Toowoomba Theatre after hanging herself after being imprisoned in a local reformatory. Actors going down to the dressing rooms are warned to watch the third step, with claims that she grabs people by the ankles with her thin, invisible hands. Then there's the ghost of 23-year-old Maggie Hume, who, unmarried and pregnant, poisoned herself in 1891. And there's Mrs. Perkins, the wife of the local brewery manager, and she nowadays haunts the Toowoomba railway station. She was apparently killed by a train when her shoe became trapped in the tracks at a local level crossing. Tim Mendham from Australian Skeptics says, while many believe in paranormal visitations, others, the skeptics among us, say it's often just possums in the roof.
It is actually the second largest inland city in Australia, the largest being Canberra. It is about 125 kilometres west of Brisbane, so it's not quite in the outback yet, but it is far. It's a historic town. You find a lot of buildings there from the mid-1800s, and it's also supposedly Australia's paranormal capital, by which they mean ghosts, right, by and large. There's supposed to be at least 40 different ghosts hanging around Toowoomba. It's not the biggest place in the world, obviously, but there's about 40 different ghosts hanging around that are noted characters in various places. A key place is apparently the Royal Bull's Head Inn, which is not very big, but it's old. It's sort of single floor. It was previously a shack, I think, actually, and adapted and built up, etc., to become an inn. It's not an inn anymore. It's now a National Trust or a Queensland Trust building you can walk through and see how people used to live. But the interesting thing is that there's various reports also about Toowoomba and how exciting it is for this. And this is another place where you get ghosts who die in one place but then end up in someone else. They're haunting a different building to where they actually died, and they never quite figure out how that works. A lot of people claim it's haunted. They go in there and they get very scared. There's different buildings. Obviously, there are people doing ghost tours and that sort of stuff. One of the saddest things, actually, there's a website about top things to do in Toowoomba, put out by the Queensland Tourism Authority. 15 totally unique things to do in Toowoomba, and none of them ghosts. And I think, well, this is Australia's paranormal capital. I think they should at least mention it in the top things to do in Toowoomba.
Well, that's immediately what I thought when I saw this story. I figured, well, obviously the city fathers have worked out where their tourist dollars are coming from, but that surprised me.
Yeah, no, there's obviously the tourist fathers and the tourist brothers or something, or sisters or whatever, who are, the ones who are doing the tours and writing the books and that sort of stuff are doing okay. There's enough skeptics, though, in Toowoomba to say, no, not really. It's not that scary a place. A nice place to visit, nice views, because part of it's up high, gardens and old buildings and that sort of stuff. So obviously well worth a visit one day, Stuart. You should go there and you can wander through the art galleries and the bowers of various trees and that sort of stuff. But ghosts, I wouldn't go there necessarily all the way to Toowoomba to try and sort of meet some ghosts, because you may or may not have any luck.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.